Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. I am going to discuss now abnormal molar mass. Abnormal molar mass. We have seen that in solution, if you want to calculate molar mass of solute, then generally it will come exact. What was the theoretical? That will be experimental. Error may be there, but it will be like that only. But in some cases, it is not like that. Means some molecules are like that. If you will dissolve in water, then it will ionize. Means dissociation takes place. As for example, NaCl. If you will dissolve NaCl in water, it will break into sodium and chloride ion. Means one molecule becomes into two particles, cation and anion. But in case of glucose or sucrose or fructose, if you will dissolve one molecule in water, it will be only one molecule. It will not dissociate. Hence, its molecular mass will be same. What is the theoretical? Experimental also will be the same. But in case of NaCl, KCl, magnesium sulfate, potassium sulfate, it is not like that. Because after dissolving in water, it ionizes and it gives NaCl will give 2 ions, KCl will give 2 ions, means K plus Cl minus. Potassium sulfate will give 3 ions, 2 potassium ion, 1 sulfate ion. Then due to this dissociation, it affects the vapor pressure, because if number of particles or ions will increase, number of particles you can tell, if it will increase, then vapor pressure will decrease, because it will block the solvent molecules like water to come up. Generally, if nothing is there, only water is there, then their molecules will come to the, because above the surface of water, then its vapor pressure will be more, maximum. But if something is dissolved, then they will block the path of these solvent molecules. It will create problem for them to come up. That's why after adding some things like glucose, like NaCl, KCl, whatever way, then less solvent molecule will reach to the vapor phase. Then its vapor pressure decreases. Already you know all the things. Then here, in case of abnormal molar mass, that if you will dissolve, you are dissolving one, but in solution is becoming 2 or 3, then it will affect the vapor pressure of the solvent. Particularly in general, water is considered as a solvent, but maybe other solvent also, organic solvent like benzene, acetic acid. Benzene, generally benzene, chloroform, carbon tetrachloride, all things may be used. Then in this situation, that vapor pressure will be less. If it will ionize, then its vapor pressure will be less. And when its vapor pressure will be less, then boiling point will be more. Reverse. Okay. When vapor pressure is less, then boiling point will be more. Why? Because less vapor pressure is there. Then it will take, you have to heat more to become vapor pressure equal to atmospheric pressure. That's why it will you will require more temperature, and boiling point will increase. Boiling point will increase or increases. And boiling point, when boiling point will increase, then boiling point and molecular mass is related inversely. If boiling point will increase, then molecular mass will decrease. Molecular mass of the solute which is dissolved in water or any solvent will decrease. This is the case here. Then one more cases may be there. First, when it will dissociate, when a molecule dissociate into more than 2 ions, and other possibilities also there, that you are suppose you are dissolving some molecules like acetic acid or benzoic acid, you have dissolved, then what will happen, that after dissolving, you have dissolved only one molecule. Suppose you have dissolved only one molecule, some molecules you have dissolved. But what will happen, that in the solution, means in the solvent, suitable solvent, what will happen, that 2 molecules will become 1 molecules. Means association may take place. Acetic acid, as for example, 2 molecules of acetic acid becomes 1 molecule, means CH3COOH. 2 molecules of CH3COOH, that will become CH3COOH whole 2. Then here association takes place. 2 molecules are becoming 1 molecule. Then in solution what will happen? Now you have added more molecules, but it becomes 50% due to association. Then it will also affect the vapor pressure. Now more vapor pressure will, more solvent molecule will reach to the vapor pressure. You were expecting that only you have added, you can say many molecules you have added, but became half because of dimerization. 2 are becoming 1. Then what you were expecting, it will give just a adverse effect. Now vapor pressure will be more because 2 are becoming 1. Then more solvent will go to the vapor phase. Then in case of association, vapor pressure increases, and when vapor pressure increases, then I told you that boiling point will decrease because both are inversely proportional. Vapor pressure increases means boiling point will decrease because vapor pressure is more. Then quickly if you will heat, then quickly it will, more vapor will become, more solvent will vaporize, and quickly it will become equal to the atmospheric pressure. That's why it's a boiling point will decrease. And when boiling point will decrease, then again molecular mass and boiling point is inversely proportional. Means if it is decreasing, then molecular mass will increase. And how much it will increase? Then if it is becoming 2 is becoming 1 in case of dissociation, 1 is becoming 2, then it will multiply by 2. Okay, it will multiply by 2. Okay, because it is becoming double. 1 is becoming 2, hence vapor pressure will be less in that ratio only, and molecular weight again it will be that ratio only. Means in how many molecules it is associating how many molecules are becoming one, or how one molecule is coming, how many after dissociation, how many ions are giving or particles are giving. In that way, in that ratio, it will increase or decrease. Correct? Then this actually is called abnormal molecular mass. And what I have discussed, that is in general, if molecules will not associate and it will not dissociate, then it will give as it is. What is the theoretical molecular mass? That will be experimental molecular mass. Little error may be there, 1.5% or so, that is a different thing. But it will not become like a double or triple or 1 by half, m by 2 or m by 3. It will not like this. Okay. It will be theoretical is equal to experimental in general case, when it will not associate or when it will not dissociate. Then this is actually called, abnormal molar mass. One example I am giving you, that if we dissolve 1 mole of KCl, potassium chloride, that is its molecular mass is 74.5, KCl 39 plus 35.5, that is equal to 74.5. Then if we dissolve 1 molecule of KCl in water, we expect 1 mole each of potassium and chloride ions into the each mole of potassium and chloride ions to be released in the solution. If this happens, there would be 2 moles of particles in the solution. If we ignore interionic attraction, 1 mole of KCl in 1 kg of water would be expected to increase the boiling point by 2 into 0.52 Kelvin. See, it multiplied by 2 into 0.52 Kelvin. That is equal to 1.04 Kelvin. For 1 mole it was 0.52 for 1 particle. Now it is becoming double. That's why it multiplied by double. Then boiling point, you have seen that due to this dissociation, it increased. 1 became 2, then boiling point also became 2. Correct? Because vapor pressure became less, then boiling point will come more. Then how much? Then 2 times. Correct? Now, if we did not know about the degree of dissociation, we could be led to conclude that mass of 2 mole particles is 74.5. 74.5 will come for 2 mole. It is 1 mole, but it is becoming 2 mole. Okay, and the mass of 1 mole of KCl would be half of original. Theoretically 74.5, but now its a molecular mass will be half, because boiling point and molecular mass is inversely proportional. Okay, then its this molecular mass of KCl will be 37.25 gram. This brings into light the rule that when there is dissociation of solute into ions, the experimentally determined molecular mass is lower than the true value. Okay. Then I have given example in case of dissociation. Now another example I am giving you as association. Molecules of ethanoic acid, which is also called acetic acid, dimerize in benzene. If you will add acetic acid in benzene, it will dimerize due to hydrogen bonding. This normally happens in solution of low dielectric constant. Low dielectric constant meaning, if high dielectric constant means solvent will their solvent molecules will have some charge, just like water, H plus OH minus, positive and negative charge it develops. Then this charge, now it is polarized, positive negative, then this charge will attract salt, you can say salt molecules or ions. Positive will attract to negative, negative will attract positive. Then it will help in dissociation. That's why if it is a dilute solution, then what will happen? Means solute you have added very less in comparison to solvent. Then in that situation, this effect will be less. Dielectric constant value will have less effect. Then this, what I told you, acetic acid, it will dimerize in benzene, and generally when it is solvent has dilute, or you can say low dielectric constant value. Then this happens due to dimerization and hydrogen bonding. Hydrogen bonding takes place, means two acetic acid molecules will join to each other, because in acetic acid CH3COOH, 2 oxygen, 1 hydrogen is there. Then other molecule also have same. Then when both will come close, opposite charge, means near the H, if O will come, other molecules, acetic acid O will come, then what will happen? Because CH3 COOH is there, then double O is there. If near that double bond O, if H will come, then both will attract. Due to the hydrogen bonding, hydrogen bond will form and it will dimerize. Because in both molecules C double bond O is there in both molecules, and in both molecules OH is also there, COOH. Then like that way, if both will clutch, both H and O will come close, then they will make hydrogen bond. Okay, and due to that this association takes place. It can be, you can say, undoubtedly stated here that if all the molecules of ethanoic acid associates in benzene, then delta TB or delta TF. Here delta TF also it will be have same way, just like elevation in boiling point, depression in boiling point, because same formula is there. Only thing is that is for one is for boiling, other is for freezing, but it will affect in the same way, because both depends upon the vapor pressure, and vapor pressure is increasing or decreasing in both cases, dissociation or association. Hence in case of freezing point also, depression in freezing point, it will also behave in the same way like elevation in boiling point. This you should not forget. Then here I told you delta T and delta V. This will affect same way. means they will be have, you can say, differently from normal value. The molar mass calculated on the basis of this delta T or delta TF will therefore be twice the expected value. Such a molar mass that is either lower or higher than the expected or normal value is called as abnormal molar mass. Now, by seeing this type of behavior of solute, one scientist was there. His name is Hoff. It is matter of 1880. In 1880, Hoff introduced a factor I, known as Hoff factor, to account for extent of dissociation or association. The factor I is defined as I is equal to normal molecular mass divided by abnormal molecular mass. Then some factor will come 2, 3, like that you have seen. Sometimes if it is ionizing in 3 ions, like K2SO4, 2K plus SO4, then 3 factor will come. 3 factor will come. If 2 are there, like KCl, NaCl, then 2 factor will come. Then like that way, I means Hoff factor I can be defined as normal molar mass divided by abnormal molar mass. And I also can be defined in the term of colligative properties. Here, reverse way you can tell what I told you, normal divided by abnormal. Here, reverse way, no, actually abnormal is also called observed, and this abnormal is called observed, and normal is also called theoretical or calculated. 3 terms are same: normal, theoretical and calculated. All have same meaning. And abnormal and observed both are same meaning, or experimental. 3: experimental, observed and abnormal. These have same meaning. Then now I can tell in the term of colligative properties also. Then it will be reverse of this normal molar mass divided by abnormal mass. Then now you can reverse it. Means observed colligative properties divided by calculated colligative properties. Correct? In the term of colligative properties. Then this is the both are equal. I is equal to normal molar mass divided by abnormal molar mass, and also I is equal to observed colligative properties divided by calculating colligative properties. Correct? And only on the same basis you can tell also in terms of moles also. I can be also defined in term of moles. Means I is equal to total number of moles of particles after association or after dissociation divided by number of moles of particles before association or dissociation. Okay? Means in term of colligative properties and this same things, only you are telling in number of moles. Okay, then 3 relation I have told you. First, I is equal to normal molecular mass divided by abnormal molecular mass. And second, I is equal to observed colligative properties divided by calculated colligative properties. And third, total number of moles of particles after association / dissociation divided by number of moles of particles before association oblique dissociation. Correct? This three relation I have told you, and all are related to IE only. Means I can know in this three way. Here abnormal molar mass is experimentally determined. Abnormal, I briefed you that abnormal molar mass is equal to experimental. Means here abnormal molar mass is the abnormal molar mass is the experimentally determined molar mass. Correct? Abnormal molar mass is experimentally determined molar mass, and calculated colligative properties are obtained by assuming that non-volatile solute is neither associated nor dissociated. Then you will calculate theoretical or normal. Okay, this is very, very important. And this value of I am talking about value of I. In case of association, value of I is less than unity. In case of association, less than 1. Don't forget. Always it will be less than unity, means 1. For example, the value of I for the aqueous solution, aqueous solution of KCl. Already I discussed the value of I for aqueous solution of KCl solution is closer to 2 or close to 2, while the value of ethanoic acid in benzene is nearly 0.5, means half. 0.5 means half. Then this you have seen that value how it is affecting. And if we want to include want of factor in these 4 properties, because that property is for general, when it will not dissociate or not associate. For that, what I discussed, that is in general, that now it will associate and dissociate. Then now this your all expression you have to modify, means final expression you have to modify. Then what you have to do? What modification you will do? Then it is very simple. Just you multiply by I in all 4 expression. Means lowering of vapor pressure, elevation in boiling point, depression in freezing point, osmotic pressure. Whatever formula is there for delta T or delta T, in that you multiply by I. Means want of factor, means delta TV, that is equal to first I will tell about the lowering of vapor pressure only. Relative lowering of vapor pressure. Relative means in relation to, I can say, highest vapor pressure is any solvent has highest vapor pressure. Then relative means like that you are comparing with the you can say standard or you can say pure solvent. Then pure solvent is P0, you know. P1 naught is pure. Then in comparison to P1, what is the difference? Then P1 0 minus P1. P1 0 minus P1. P1 is for, you can say, solution. Then P1 0 minus P1 divided by P1 naught. This is actually relative lowering of vapor pressure, and that is equal to, you know, N2 divided by N1. That you know, N2 divided by N1 means number of moles of solute divided by number of moles of solvent. Then here you have to multiply by I. want of factor I. Hence, new formula will become P1 naught minus P1 divided by P1 naught is equal to I upside you can write, you have to multiply into divided by N1. Like that way, elevation of boiling point means delta TB, that is equal to delta TB is equal to, again you know that it is a Kb into a small m, molality, small m. Then now you just multiply by I. Then now it will become delta TB means elevation in boiling point is equal to I into Kb into m. Like that way, depression of freezing point delta Tf is equal to I into Kf into small m, molality, small m, Lity, and osmotic pressure of solution, that is equal to pi is equal to, that you know osmotic pressure is equal to N2 into RT divided by V, N2 into RT, gas constant temperature divided by volume. In that you multiply by I. Then osmotic pressure of solution pi is equal to I into N2 into RT and down only V. Okay. Then this everywhere you have multiplied by I. Then now all four expression now modified, and if you will get situation like that, numericals will be asked based on this modified formula only. Then this actually dilute solution, if solution is dilute, then solute will dissociate maximum, because they will get chance to dissolve, maximum chance it will get to dissolve if solvent is solution is dilute. Dilute means more solvent, less solute. Then in that situation they will dissociate maximum. Dissociation will be maximum. Okay, near about, as for example for KCl, NaCl, it will reach to near about 2. Exact is 1.97. For NaCl, for KCl again same way 1.98. And magnesium sulfate, it is giving 2 ion, then it will be 1.82. And K2SO4 roughly 3 means 2.84. Okay. Then what will be the I factor for all the things? Then you know I factor, that is for NaCl you can write to 1.97 is there, you can write it to 1, and other KCl 1.8 is there, you can write 2.0 means roughly you can write in a whole number 2. 1.82 for magnesium sulfate you can write it 2. 2.84 for K2SO4 you can write 3. Then this I have discussed about the abnormal molecular mass. Now I am going to solve numericals based on abnormal molecular mass, means based on want of factor. This type of question is generally asked in IIT advanced, and generally question will be long, but after understanding you can solve it easily. Concept is very, very important here. Then now I am going to read the question and then I will solve it. Okay. Try to understand the question. 2 gram of benzoic acid. 2 gram of benzoic acid. Its formula is C6H5COOH. Dissolved in 25 gram of benzene. 2 gram of benzoic acid dissolved in 25 gram of benzene shows a depression in freezing point equal to 1.62 Kelvin K. Molar depression constant for benzene is 4.9 kg per mole. What is the percentage association of acid if it forms dimer in solution? This is the question. Most of the things what you require is given. Now 2 gram of benzene means W2 is given. W2 is given. And formula is also given, benzoic acid C6H5 COOH. Correct, because it will help you in calculating the number of moles, molecular mass you can calculate. And W1 value is also given, 25 gram of benzene, 25 gram, and benzene C6H6 is there. If you require, you can calculate molar mass also for solvent. Then next thing is given, freezing point is given, depression in freezing point is given 1.62 Kelvin. Okay, depression in freezing point. And again Kf value they have given, Kf value. Molar depression constant of benzene is 4.9 kg per mole. K means Kelvin, kg per mole. Then now this data is given. Then now you have to find out percentage association of acid if it forms dimer in solution, means association is there, dimer, 2 molecules are becoming 1 molecules. That is the case of association. Then now all things are there. Then how will you solve these things? You have think back calculation. It will be very good. Means you have to calculate these things. Percentage association you have to calculate. Percentage association. Then you start thinking from this. What do you want to? What do you require to calculate these things? Percentage association by calculation. First you think in your mind, then you start solving. Then association, percentage of association you have to calculate. Then already I told you 2 moles becomes 1 moles, means 2 moles of benzoic acid to C6H5COOH, sign of reversible, that is giving C6H5COOH whole 2. This you have to write. Okay, this you have to write before calculating. This is equilibrium. Both are in equilibrium. But I told you always 100% it will not dissociate or associate. You have seen 1.98, 1.28, 2.8, like that way will be there, little less than 100%. Correct? That's why it is asking, question is asking degree of association, because 100% it will not associate, maybe close to whole number. Then that you have to calculate. And now here big hint is there for you that sign of equilibrium is there. 2 benzoic acid is converting one molecule, 2 into 6 C6H5COOH, sign of equilibrium, and you are written C6H5COOH whole 2. Then this reaction equilibrium you have to write before solving. Okay, because this will help you. Then now here you have to calculate percentage association. Then now you remember equilibrium chapter. There, suppose one distance this two, generally two will be, two here in association, 2 mole is becoming 1 mole. 2 mole is becoming 1 mole. Correct? Then now, keeping in mind this, you have to calculate. Association, percentage of association. Then now, how will you calculate that? You listen. Okay, I am telling you just to try to understand. If x represents the degree of association of the solute, then we would have 1 minus x mole of benzoic acid left in unassociated form. If x mole is associating, then 1 minus x, 1 means full, 100%, like that you can consider. Then x mole of benzoic acid is associating, then 1 minus x will be undissociated. Correct? This is the first concept. Now second, that if X molecule is associating, then it will form how many moles after association? After association, how much mole it will form? X mole is associating. Then it means 2 mole is becoming 1 mole. Then X mole is becoming half mole, X by 2. X mole become X by 2 because 2 mole is becoming 1. Then X mole is becoming X by 2. X by 2 means you will get moles of this association, number of moles associated, that is the X by 2. Then now you can say at equilibrium position, total number of moles, how many moles will be there at equilibrium position? Then what is left out and what it is formed, add it both, means 1 minus x plus x by 2. 1 minus x plus x by 2. Then you will get 1 minus x by 2. Correct? 1 minus x plus x by 2 means half it is going, then half it will remain. It means 1 minus x by 2. Correct? At equilibrium, 1 minus x by 2 will remain. Then now here x by 2 at equilibrium position, you got total number of moles. Then this total number of moles at equilibrium, that is equal to I. That is a Van't-Hoff factor. Remember that total number of equilibrium is equal to I, Van't-Hoff factor. Correct? Then now you can write that Van't-Hoff factor I is equal to normal molar mass divided by abnormal molar mass. Correct? Then now I value is equal to 1 minus x by 2. Don't forget. Then here this x is there. X value you don't know. Normal molar mass you don't know. Abnormal mass you don't know. But data is there. You can calculate all these things. Then because it is going to help you, this relation, only by this relation you will get the association. Okay. Then first to calculate, then again I will tell you, because the next step is the percentage. Okay, percentage association you will calculate. Then first just you normal molar mass of solute you can calculate. Normal molar mass of solute. Then just they have first they have given in gram. 2 gram is there. Then 2 gram you convert into the molar mass. First things. Now you have started, or now you can start actually calculation. Then 2 gram you convert in mole, and 2 gram divided by molecular mass of benzoic acid. Then benzoic acid molecular formula easily you can calculate. That is a 6,6H5COOH. C is equal to 12, H is equal to 1, oxygen equal to 16. Add it all. Then you will get you will get here, or direct this solute. This they have given 2 gram benzoic acid. Then here W2 is equal to 2 gram. And Kf is equal to, they have given 4.9 Kelvin kilogram per mole, and W1 is equal to 25 gram, and delta T F is given 1.62. Then here you want normal molar mass, then an abnormal molar mass, both you want. The normal molar mass quickly will convert, that is not a problem, but abnormal means experimental. How will you get experimental? Then experimental molar mass, that is for that they have given the data. All data is given for that purpose only. Abnormal, experimental, what you are telling. Then formula you know, M2 is equal to Kf into weight of solute into 1000 divided by W1 means weight of solvent into Kf. All data is given. Then M2 you can calculate very easily. You after putting all this value, you will get the result 241.98 gram, means 4.9 into 2 into 1000 divided by 25 into 1.62. After solving, you will get 241.98 gram per mole. Then now you got the abnormal molar mass. Abnormal molar mass you got. Okay. Then now after that what will you do? You are knowing normal molar mass you have to calculate. Abnormal already you are knowing, correct? Then now after that if you calculate normal molar mass of benzoic acid, you add all. C6H5 means 12 into 6 plus 1 into 5 plus 2 oxygen is there, and 2 into 16 plus 1, and the last hydrogen is there, correct? Then you add, it will become 122. Then I will be, I is equal to 122 divided by 241, and I is equal to 1 minus x by 2. I is equal to 1 minus x by 2. Then now easily you can calculate x, because now this I is equal to 122 divided by 241, and that is equal to 1 minus x by 2. Then after solving you will get x value, that is the x you will get 0.992. See, x value got 0.992. See, roughly you have reached to 0.992, one only, 0.992, only 0.8 difference is there. Then this you can say X you calculated. Therefore, degree of association of benzoic acid in benzene is 99.2%. Correct? How? Because in one gram, this you got X value, X is equal to, that is a 0.992. Then this X 0.992 is from X. From X you have got like this, X value, 1 minus X. Then you got the X value 99.2. 99.2 you can say you got. Then you can convert it, 0.992 you can convert it percentage. In one molecule is giving 0.992, then 100 molecule will give how much? You have to multiply 0.992 into 100. 1 mole is giving 0.992. Then 100 multiply by 100. Then you will get 99.2. Correct? Means 0.992, then means 9992 divided by 1000 upside 100. Then this will get 9992 divided by 10 means 99.2. Then see how you got, means 1 minus X. That is very, very important to think that X is dissociating, means 1 minus X is not dissociating. Then 1 out of 1 mole, 0.992 is dissociating. Correct? Then 100. Then this is the this calculation. You think in a back way, that what do you want, that you think, and then go backward calculation. In mind, first you think what you have to do, and then if it is clear in your mind, okay, this is the route to get the final result, then you do start calculating. If your mind is telling okay, then your hand will also tell okay. Correct? Now next example I am giving you, next concern numericals. Next numericals, that is also very, very important, and it is long. Okay, but here again full of concept. If concept is clear, then you can solve the numericals, no problem at all. And question may be long. What I am telling, that long question they will not ask for even for advanced, because time will be less. They will give such type of this thing question that you can solve in shortcut way also. Okay, then here a question you have to understand, and then concept you have to clear, because they will give such type of the question they will set, you can solve it without taking too much distance. We can solve it, it will not take too much time. Like that way shortcut method will be there. Then while setting question they will give like that if students are knowing the concept, they can solve in less time also. Now next question I am reading. 0.6 ml of acetic acid, means CH3COOH, having density 1.06 gram per mole, is dissolved in 1 liter of water. The depression in freezing point obtained for the strength of acid was 0.0205 degrees centigrade. Calculate the want of factor and the dissociation constant of acid. This again I am reading one more time. 0.6 ml of acetic acid CH3COOH having density 1.06 gram per mole is dissolved in 1 liter of water. The depression in freezing point observed for this strength of acid was 0.0205 degrees centigrade. Calculate the want of factor and the dissociation constant of acid. Okay, this is the question. Here what is given? Then see 0.6 ml of acetic acid means solute they have given in term of volume, not in gram, it is in ml. First things, acetic acid formula they have given so that you can calculate the molecular mass of solute, and its density is given 1.06. Now you can understand density they have given, then now density is equal to mass by volume. Density they have given 1.06 gram per mole. Gram per mole means 1 mole weighs 1.08 gram, means 1.08 gram means 1 mole. Then 0.6 ml, 0.06 ml, how much? You have to calculate. But here they have given density is equal to mass by volume. Then density is given, mass is given, volume is given. Then mass quickly you can convert. You can get the mass. Density is equal to mass by volume, and density is 1.06, and mass you want to calculate volume. Volume is given 0.6 ml, hence mass quickly you can convert mass of acetic acid. And if you want to calculate number of moles, then molar mass, acetic acid you can calculate very easily, CH3COOH, C is equal to 12, CH3, 3 into 12 plus again 1 carbon is there, then plus 12, again plus 2 oxygen, 2 into 16, and in the end H is there, then plus 1. Then you can calculate the number of moles of acetic acid also. Then number of moles of acetic acid will become 0.6 into 1.06. This is converted into the gram. Then gram divided by molecular mass. Then molecular mass of acetic acid after adding this atomic mass, you will get, you can say 60 gram. That is the molecular mass of acetic acid. Then divide it by 60. Then you will get number of moles of acetic acid, that is the 0.0106. 0.0106 mole. That you can tell N. N means number of mole. Then okay, you have to calculate the number of mole, you know. If gram is given, the gram is not going to solve your problem. You have to convert it into the mole. Okay, in almost all you can say solution chapter, whatever numericals will be asked, if it is given in a volume, you convert into the gram, and gram you convert into the mole. Don't forget important things I told you. If it is given in ml, volume they have given, convert volume they will give, the density they will give. Sure. If volume is given, density is given. That simply just to multiply, you will get the mass. Mass when you are getting, divided by molecular mass, you will get number of moles. This you have to do, number of moles. This is the common way. Now you have to calculate, I told you back calculation, you should try to do. Then your problem will be easy. Then you have to calculate want of factor and dissociation constant. Two things you have to calculate. Then want of factor means I. I is equal to want of factor. Then how will you calculate I? Then this I, what I discussed in the last numericals. Here again this acetic acid. Now you know that at equilibrium position, actually equilibrium chapter is very, very important in solving the numericals. Solution numericals, particularly in gaseous and solution. Gaseous, these things, these things, gases related problem is there, and solution related problem is there. Then there equilibrium chapter will help you. Then here again acetic acid dissociates into acetate ion and hydrogen ion. CH3COO 1 minus plus hydrogen H plus. It dissociates. CH3COOH sign of equilibrium. CH3COO 1 minus plus H plus. This is the equilibrium. This is the equilibrium reaction. Then now here now you have to apply these things. Here only you have to think. This is the main things for calculate. It will help you in calculating the IE also, or in calculating the dissociation dissociation constant of acid. Dissociation constant, just like association constant. Here you have to calculate dissociation constant. Then now you know that 1 mole of acetic acid will give 1 mole acetate ion and 1 mole hydrogen ion. 1 mole is dissociating into 2 acetate ion and hydrogen ion. Then both it will give 1 1. 1 mole acetate ion, 1 mole hydrogen ion. Then now suppose if it is n mole, because you don't know how many moles was there. They have given only that 0.6 ml. They have added. They have added. Then 0.6 is in 0.6 ml is there. Then now actually you have converted into n. Correct? N value you are knowing. Then here for calculation purpose you think that 1 mole is giving 1 mole acetate ion, 1 mole hydrogen ion. Then if it is n mole, then it will give n mole acetate ion and n mole hydrogen ion. Then now you have to think also that 100% dissociation will be not there. Maybe 99%, maybe 98%, 97%. Correct? Then then you think that one out of 1 mole only X mole is dissociating. X mole is dissociating. Okay. Then it will give X mole acetate ion, X mole hydrogen ion. Out of 1 mole only X mole is dissociating. Then it will give in equal number cation and anion, means acetate ion X mole and hydrogen ion X mole. And what will be remaining in solution? 1 minus X. 1 minus X will be remaining acetic acid. Correct? Then you have calculated for 1. Out of 1 X mole dissociated, 1 minus X is, you can say, not dissociated, undissociated. And X mole acetate ion, X mole hydrogen ion, you got means equal number. Then if it is n mole, suppose acetic acid is n mole, then you multiply everywhere n, then 1 minus X was there, now n into, in bracket 1 minus X will remain undissociated, and nx mole of state ion and nx mole of hydrogen ion will form. Correct? Then after that you have to calculate dissociation constant. You have to calculate dissociation constant. Then now you are knowing the expression for K expression. Because it is acid, you can tell as a Ka. A means acid, Ka. Then for K is equal to what? Ka is equal to, that is the concentration of products divided by concentration of reactant. Then here concentration of products, two products are there. A state ion, concentration of a state ion into concentration of hydrogen ion divided by concentration of acetic acid. Then here upside numerator, that is the Nx into Nx divided by down N into 1 minus X. Correct? That is equal to K, Ka. Then now you require here this things, N value and X value. N value and X value. Then N already you have calculated. N, a small n value, already you have calculated number of moles. Then now you have to calculate X. Then now you think, how will you get the X? Then just last numericals I told you that at equilibrium, how many moles are there? That is equal to I. Then you will get I if you want to calculate, then you have to add all, you can say, moles. All moles present at equilibrium means N in bracket 1 minus X, that is the number of moles of acetate, number of moles of undissociated acetic acid, plus number of moles of acetate ion, plus number of moles of hydrogen ion. Add all three. Then it means N in bracket 1 minus X plus Nx plus Nx. You add it. Then you will get because N is everywhere present, N you can take common. Then you will get in bracket 1 minus X plus X, again plus X. Then 1 minus X plus X will cancelled out. Then in bracket only 1 plus X will remain. Outside N in bracket 1 plus X. Then this is the total number present at equilibrium, and that is equal to Van 't Hoff factor I. Then now I value you are knowing, that is the N into in bracket 1 plus X. I value are knowing. Then this you are knowing, this is actually abnormal. This is responsible for abnormal molecular mass. Correct? This I, what you have now in this number of moles, that is equal to, you can say, abnormal. Then now what is the normal? Normal was N. Colligative properties according to that. Correct? Observed is N in bracket 1 plus X divided by N according to colligative properties. Then this is equal to I. This is the formula. I is equal to N in bracket 1 plus X divided by N, means observed divided by normal, a small n. That is equal to I. And I is equal to what? Then you have here this thing. What is the value of I? Then that you can calculate. Data is given. Then direct formula, molality How will you calculate want of factor? That value, then already told you that want of factor I is equal to observed freezing point divided by calculated freezing point. Then observed I can say freezing point. How will you calculate observed freezing point? Then to calculate observed freezing point, all data is given. Means molality quickly will calculate, because N you have calculated already 0.0106. Then this is dissolved in 1 kg of water. 1 kg of, in question they have given 1 liter of water. But now density, you know, density of water at a normal temperature means 25 degree. That is the 1 density. Then multiply both 1000 into 1. Then volume into density is equal to mass. Then that will be 1000 only. Hence 0.0106 divided by 1000 means it will become, after solving, 0.0106 mole. 106 this will come. This will come 0.0106 mole. Molality, that is the 0.0106 mole per kg. Molality you have calculated. Then molality you have calculated, then Kf formula delta Kf. Delta Kf, because you want to calculate depression in this thing, want of factor. Then now for that you require these things, observed and calculated freezing point. Then calculated freezing point and observed, now you will calculate. Then delta Tf you have to calculate. Delta Tf you will calculate. Then after that delta Tf is there. It's just like a boiling point. Suppose 2 degree raised. Delta T, suppose was 2.1 degree. Then what will be the actually 100.2? Suppose boiling point was there. Elevation in boiling point. That total boiling point was suppose 100.2. Then what is the delta T? 100.2 minus 100, that is a 0.2 degree. Then if you are knowing the 0.2 delta T, then boiling point of solution also you can calculate by adding 100 plus 0.2. Like that way, depression in freezing point, delta T you are going to calculate. And if you will calculate delta T value, then 0 degree, you know, 0 degree is the these things for water freezing point. Then 0 minus that temperature. Correct? Then for that purpose, delta Tf you are calculating, so that you will get freezing point. Experimental you will get, okay, or also you can tell observed. Then now delta Tf you can calculate very easily, because value is given. But here again you should understand, here for these things, for water they have not given this value, Kf value, they are not given in question. You have to remember, I already told you some important Kf value and Kv value for some common solvent you should remember. Then here you can say for water this Kf value is 1.86 Kelvin kg per mole. Don't forget. Then delta Tf is equal to, you know that Kf into a small m. Then a small m you have calculated, Kf value is 1.86, you have to remember. Then you will get delta T value, that is a 0.0197 Kelvin. After multiplying you will get this value, okay, 0.0197 Kelvin. Then now easily you can calculate the want of factor. Then observed you can say these things, observed freezing point observed freezing point. Now you got that is this one top factor, the delta TF value calculated 0.0197 K. Then now this depression in freezing point, they have given 0.02045 in question they have given, freezing point they have given. Then from this freezing point they have given 0.0205 degree centigrade they have given. Then from this value, delta T value, decrease it. That will be actually calculated or theoretical. Then from the 0.0205, that is the actually given, observed, correct. From that delta D value will minus, then you will get calculated. Then after deducting, value will come 0.0197 K. Then after this solving, you will get I factor, you will get 1.041. That is the I factor, 1.041. Then now I factor value, actually you wanted to know I value. Then now you got the I value. Means I value you have written that time n 1 plus x divided by n, correct. N in bracket 1 plus x means observed divided by n, normal, that is what I. And this I you have calculated, that was equal to 1 plus x, okay. 1 plus x at equilibrium position, total number of moles, you have calculated 1 plus x, that is equal to I. And that I is equal to, what is the value of I? Now we have calculated 1.041 value of I. Then 1 plus x is equal to 1.041. Then x easily you can calculate. 1 plus x is equal to 1.041. Then what is the value of x? Then just deduct 1. Then you will get x is equal to 0.041. X value also you are knowing. Now n value also you are knowing. Then in a Ka expression means a product of concentration. Okay, product of concentration divided by reactant. That value there means concentration of state ion into hydrogen ion divided by acetic acid. That all value now you are knowing. N value you are knowing. N value, that is the 0.0106, and x value now you calculated x value, that is a 0.041. Then you put all value. Then state ion and hydrogen ion same number, means 0.0106 into 0.041. You have put the value, that n and x. Again for hydrogen same thing, 0.0106 into 0.041 divided by, now nx was there, the n is equal to again 0.0106, and in bracket 1 minus x was there, 1 minus x, then x is equal to 0.041. All value you have put. After the calculation, you will get 1.86 into 10 to the power minus 5. 1.86 into 10 to the power minus 5, that is equal to Ka, dissociation constant of acetic acid. See here, this question here, 3 concept you have used. 3 concept. First concept, what was the required? That is the Ka expression. Ka expression, that was the must. According to the question they were asking, you have to apply this. No way. You have to calculate this. This expression you have to remember. One concept. Second concept, that is to get the value of x or n, then n value, okay, no problem, you calculated the number of moles, correct, that is the common way. Then I is equal to observed by normal, colligative properties, observed freezing point and normal freezing point you wanted to calculate. Then to get the value of observed value, it is given, observed value is given, a freezing point, then calculated is not given. Then for that purpose, second concept you have utilized, that is the delta TF. And if you got the delta TF, then from the observed value, you have deducted this value, then you got calculated. Then now when you got both, then you got the I value, correct, and this I value you got in the term of 1n into 1 plus x. This value you got in term of I factor, you got in terms of n in bracket 1 plus x, correct. This is actually third concept you can tell. First concept expression, second concept concept that is the I formula you have utilized. Second you can tell delta TF, second, and third is this I means a want of factor. Three formula you have used, and for the n, that is the common general, total 4. Then you got two concept to get a value of want of factor and its dissociation constant. These 4 things you have considered, correct. Then in examination, so long question they will not ask in the multiple choice question, but here it will be divided into 2 parts. Either they will ask calculate want of factor or calculate dissociation constant, any one. But for all the things you required full concept. If concept you are knowing, then from anywhere you can take the turning, from anywhere. Then I have this solved 2 numericals, and one was based on association, other was dissociation. All numericals will be actually you can solve on these 2 concepts. Okay, this was long, but it is very important numericals. On this concept, other numericals easily you can solve. Then this chapter finished. This solution chapter 100% finished. Next class I will start a new chapter, that is electrochemistry. Thank you.